This is our neutralization basin here. What this is designed to do is neutralize the chemical backwashes that our membranes go through. Every 45 minutes, our membranes go into a backwash, and that's just to flush out everything that they've caught that the clarifiers didn't. And this is one of the improvements that we've made this winter, was actually sucking it down to the bottom. It's about 25 foot deep, and completely cleaning it out and putting it back into operation. This is the filter feed basin over here. It was one of our larger obstacles this winter that we've already tackled. We contracted this to be cleaned out as well. It's about 25 foot deep. It was full of sediment that carried over from the clarifiers from last winter. We were able to completely drain that. It happened overnight, as there's less water demand in the city at night. It took place from about midnight till about 3 in the morning. They were able to completely clean it out, and it's working properly now. We're working closely with the county. They're actually going to be helping us out clearing the dam, as you see behind us. It'll be all, this project's set to start on Monday, this coming Monday. As you can see, the white sign over there is actually our intake structure, and that's where we pull from the lake to treat the water for the city. So from the dam, the water comes in through the intake, comes in through the 2 raw lines. We have 2 lines that feed the plant. We alternate them every week to ensure that they're exercised properly. The water then comes in through the splitter box, as we call it. This is where all of the chemical that we use to treat the water is injected. So from the splitter box, the water then goes into our 2 clarifiers over here. Clarifier 1 and Clarifier 2. Clarifier 1 is the clarifier that will be completely rehabbed next winter. I don't know how good of a shot that is, but these are our raw lines right here. The lines that feed the lake water into our treatment plant. This is clarifier 1, the larger of the 2 that we have. How these work: you have the mixer in the center. The dirtiest of the water, the beginning of the water, comes up through the center, and the mixer's mixing the chemical. It's called a coagulant, and what that does, the coagulant binds to the organics in the water, and essentially when it binds, it makes it heavier, so it settles. So it's going up there and grabbing all of the dirt in the water, and it makes it settle, and it creates a blanket down here. And these are upflow clarifiers, meaning that the water comes up. So as that water comes up through that blanket, it acts as like a filter almost. And the cleanest water comes up to the top and enters these pilot holes in the troughs. Once it goes into these troughs, it comes into the center ring and then discharges into the discharge. And from that discharge gets sent to the filter feed basin, as you can see over there. So part of the rehab is actually going to be to replace all of these troughs here. They'll all be brand new. They'll be stainless steel and coated. Also, the center ring will be replaced, and there's a bell below the water level. All of that's going to be repainted and primed, to get as much life out of it as possible. We actually utilize this to do settling tests. We'll actually take samples from those center rings, and we can actually time it and see how much settling we're achieving, and it gives us an idea of how well our chemical dosage is doing. This is a turbidimeter. This measures how clear the water is. So we actually measure the turbidity as well as chlorine residual throughout the entire treatment process. So one of the cool things about the water plant is that we actually recycle as much water as we can. The water backwashes actually get flushed over here to these concrete lined ponds, and that water then gets recycled to the back of the plant and we retreat it. It's required by the state that we take these chlorine and turbidity readings every 4 hours. We don't only meet those standards, but we exceed it, and we actually sample every 2 hours throughout the water plant. And these are the different sampling points. We have a total of eight sampling points that we test, and we run multiple tests: pH, turbidity, alkalinity, total hardness, chlorine, fluoride, free ammonia, and monochloramine are all things that we test for. We can actually walk through the entire plant via the computer here. These are those 2 raw lines that we showed you over there by the dam. The water comes in through one of the 2 pipes here, and every Wednesday they get cycled, and we'll switch over from one to the other. From there it goes into the 2 clarifiers you can see here. From the clarifiers they go over to the filter feed basin, which is the basin right behind us between the clarifier and the membranes. So you can see one pump's on. We're currently producing 1.4 million gallons of water today. From there it goes into our membranes. These are the filtration systems here. Currently we're using stage 1, as stage 2 down here is the one being replaced. We're able to check the levels of all of our chemical tanks here. So from the filter it goes into our clear well, which is this tank here. We have 3 tanks, or 3 water pumps that we're able to pump into town with. We cycle those each time we run a different one to keep them exercised. From town we have 4 water towers that we fill and constantly monitor. So as many of you know, a lot of the automation was taken out of this plant several years ago. It's something that we're constantly working on. Every budget year we will be selecting one area of the plant to put back into automation, and it's going to be a slow but methodical process to get everything back how it was originally spec'd. We're currently constructing a new office storage space at the water plant. It's going to be used to store all the lab results and data that we're required to keep for 5 to 10 years. We're actually going to be storing it here. It's going to be climate controlled and protected from the elements. We can go up here and look at it. It's by no means complete yet, but it's well on its way. You were at the old water plant. You can see the need for a climate controlled area to store all of our documents. So these are the chemical bulk storage tanks here. We currently use coagulant, LAS, caustic, fluoride, citric acid, bleach, and chlorine gas to treat the water. Each one of them's used at different stages of the treatment process. All different kinds of ball valves and fittings that our membranes use. And as you can see, we actually have on-hand parts now which are essential to keep the water plant running.